last piece, the graph of the function y equals x minus 2 squared, x minus 2 times x minus 1 squared times x plus 1 cubed. It wants us to use end behavior, x and y intercepts, and multiplicity of zeros to sketch an accurate graph. So, first things first, let me go ahead and put out my roots. I have a root at x equals 2. I have a root at x equals 1. I have a root at x equals negative 1. So I already have 3 points. By the way, the degree of this, turns out it's a 6th degree polynomial. First degree, second degree, third degree, 1 plus 2 plus 3. Leading coefficient, well, it's just a 1. There's no factor in front of, no constant in front of all these different factors. So it's a positive leading coefficient, which tells me that this is the kind of behavior I'm going to have upward behavior on my graph. So that lets me do this. Okay, now, before doing the rest of my drawing, there's one more point to get. This is the thing that's newly introduced. Let's find the y-intercept. Well, you find the y-intercept by setting x equal to 0. I've always solved the point, but remember, let's plug it in. X equals 0. This becomes negative 2. Negative 2 times, well, this would be negative 1 squared, which is 1. So I got a negative 2 times a 1. Still negative 2. And my last piece, 0 plus 1, when I cube that, that's just a good old 1 as well. Negative 2 times negative 1 squared times 1 cubed becomes negative 2. I know that the point 0, negative 2 lives on this graph. So now I have all my roots. I happen to have a y-intercept. Just gives me one more thing to work with, which is nice. Let me go ahead and start drawing. Here we go. Well, first root is at x equals negative 1, and it's a multiplicity of 3. I'm going to need to do my traffic circle type of behavior. So here I go down and now load it. Look, start to make that real flat traffic circle turn and then come out of it and resume. Great, there's multiplicity of 3. I'm going to need to get back to this next root at x equals 1, the point 1, 0, but I need to make sure that I do what? That I hit this point 0, 2. I can't turn before that or I'd miss the point. At some point in time, I'm going to make a turn point. I'll just arbitrarily put it here. And I need to come back now to my next root, which is at x minus 1 squared. What do I need to do? Even multiplicity, U-turn. Down I go. At some point again, totally arbitrary. We're not working, we're not finding these turning points. But I do know that I need to turn so that I can come back to what? So I can come back to my next root, which is a multiplicity of 1, which gives me a straight plow through. I join my end behavior, and there is a graph. See my behavior in each direction. Traffic circle, hit my y-intercept, turn around, turning point, come back to my next root, multiplicity of 2, U-turn, have to get back to my final root, turning point, away I go with a plow through because of multiplicity of 1. So there's how we do that. And this will finish section 3.2. Hopefully it's given you a lot of insight into how to build these graphs, some starting points by understanding the degree and leading coefficient, letting multiplicity help you, and then we can draw some very good and pretty accurate rough sketch graphs.